Lesson 3.1.4, we're going to be looking at complex fractions. To start out, let's review when we are solving an equation that contains fractions. The way we've solved these in the past here, when we have an equation that looks like this, 1 over x plus 2 over 3 is equal to 7. Because we have our value of x down here in our denominator, a lot of times we choose to just go ahead and get rid of the fractions. We try to clear out the fractions to make the equation easier to solve. In order to do that, we usually try to identify what the least common denominator is going to be. So what we'll do here is we'll look at all the fractions that we have and we'll list out their denominators in factored form. In this case here, we've got 3 denominators. We've got x, we've got 3, and we've got 1. In which case, these are all already factored as much as they could. They're all 3, well, x and 3 are prime, and then 1 really isn't prime, but, it's just 1. So, all right, so what we're going to do here then is, in order to come up with the least common denominator, we're going to be looking for something here that's going to be divisible by all 3 of these numbers here. So in order to find that here, we're going to take this and multiply each of them by the factors that are missing when we compare them to the other denominators. So in this case here, we have an x. So the x doesn't have a 3, so it's going to need a 3 in it, along with it there. So we're going to multiply it by 3. And we'll multiply it by 1. Same thing here with the second one. We would have said here that 3 doesn't have the x or the 1, and the 1 doesn't have the 3 or the x. Now when we look at it here, if we multiplied any one of those rows together here, we would get that 3x is our least common denominator. Now the thing is, we're not going to actually change these to be those denominators. What we're going to do is we're going to use that value to get rid of the fractions. So we're going to take this here and we're going to multiply both sides of the equation by 3x. And when we did that there, we would have had 3x times 1 is 3x over x plus 3x times 2 over 3 should equal 3x times 7, which would just be, we could say that one's 21x. And then we would always try to cancel out our common factors that appear in both the numerator and the denominator. Now you can do that all in one step. I just want to make sure in case there's any questions that people understand what we're doing. So 3 times x divided by x is going to leave us with just 3 here. And we'll have plus 2x is equal to 21x. And now it's a much easier equation to solve. So we'll go ahead here and just solve it. Subtract our 2x from each side. And we'll end up with 3 is equal to 19x, which means that x is going to equal 3/19. Now we could take it, plug it back in to check it here, but for the sake of time, I'm going to tell you that we did solve that correctly. Okay, now 3/19 would not give us 0 in the denominator, so we know it works there too. All right, let's move on to the next part. It says, what is the least common denominator for each set of fractions? So sometimes when you look at them here, like when we look at this first set of fractions here, we can tell what that least common denominator would be just by looking at it, which is totally fine here. We know here in this one that your denominators are just 2 and 5, and what number does 2 and 5 go into? Well, our least common denominator here would have to be 10, right? Because 10 is divisible by each one of those denominators. Now when we look at the second one here, this is a pretty basic one as well, but sometimes there are mistakes made on this one. So let's do what we did in that last example on the previous slide there. Let's take it, let's list out each of our denominators in factored form. So there's x. We have x squared when it's factored is x times x. And then 1 really is irrelevant most of the time here, but we'll just throw it in there in case it happened to be a different number at some point. So now when we take it here, each of them has to contain the factors in the other denominators. So when we look at this first one at the top here, right, it is missing a second x, so we're going to need to multiply it by x. And technically it already has a 1 in there, right? If we multiplied, times the 1, it really isn't going to change anything. This one technically has a 1 already as well, and then this one would have been missing the x and the x. So our least common denominator there is going to be x times x, which is x squared. That would be our least common denominator for that one. And then the last one there, you can, if you know it already, go ahead and fast forward and see if you got what I'm getting right here. But if I think about listing them out, oops, let me make that a little neater. So we have an A, a B, an A times A, and a B times a B. So when we do these ones here, when we're looking at it there, this first one up here, this A, is going to need a B, obviously, because this second one has a B. But then the third one down here has two A's, so we're going to need another A. And then this one on the bottom has a second B, so we need another B. And when we go through each of the others there, you see that this one needs two A's and a B. And this one needs two B's, and this one needs two A's. Now they all have the same factors, and when they're multiplied together, we end up with A squared, B squared would be our least common denominator for that one. All right, so hopefully remember how to do that there, and we're going to see how this is going to help us with our complex fractions. So first of all, what is a complex fraction? So a complex fraction is just a fraction that contains more fractions. So we have fractions and fractions. So how do we simplify complex fractions? Well, I'll kind of list it out in steps here, just for those of us who appreciate a procedure and thinking about things step by step. First thing we want to do is we want to identify the least common denominator for all of the fractions in the expression. So we're going to identify the least common denominator for all of the fractions in the expression. Our second step then will be we're going to multiply both the numerator and the denominator by that new least common denominator. Okay, and then afterward we would have to just look to simplify if possible. So looking at our first example on this page, we have 1 divided by pi over 2. And one thing you want to make sure you kind of focus on here is, you see we have a couple fraction bars here. This is the bigger one, which means this whole thing, if we were looking at it here, this 1 is like our numerator. And then we have this fraction in the denominator. Hopefully that makes sense there, right? So the one with the bigger fraction bar it's the bigger fraction here, and then the pi over 2 is just in the denominator here. So I'm just going to rewrite down here since I actually accidentally wrote on there and probably threw off your notes. Here we go. So we have 1 over pi over 2. So we look at this here. We have a value of 1 in the top, and then we have that pi over 2 in the bottom. If you're looking for what's the least common denominator between the fractions, we definitely have to say that the least common denominator here is going to be 2. Right? That's the only one that really has a denominator there. So what we're going to look at doing here is we're going to multiply the top of this fraction by 2 and the bottom by 2. And when you think about this value here, this 2 over 2, really 2 over 2 is the same thing as 1. So when we multiply something by 1, it doesn't change the value. So here's what we get when we do it. So we'll take it here and we say 1 times 2 is going to give us 2. And then we think about multiplying pi times 2 down on the bottom, and then it would be divided by 2. We could say like the 2's are going to cancel, and it's going to leave us with 2 over pi. And now we'll say that is simplified. That is our answer. For the second problem here, we have 1/2 plus 3, and then that is over 3/2 minus 1/5. So the first thing, remember, is we wanted to identify what the least common denominator is going to be. I'm going to do that in red over here, right? So we've got denominators of 2 and 5, and then I guess we could say 1 as well. So we already kind of did that on our previous slides there, right? We had something where we had 2's and a 5, and we said our least common denominator was 10. So our least common denominator on this one is 10. So we're going to take it here, and we're going to multiply the top of this fraction by 10, and we're going to multiply the bottom of this fraction by 10. So when we do that there, right, we're going to just go ahead and distribute that 10 through on the top and the bottom. So 10 times 1/2 should give us 5, and then plus 10 times 3 would be 30, over 10 times 3/2 should give us 15, and then 10 times 1/5 should give us 2. So when we add them together here in the numerator, we're going to get 35, and then the denominator we get 13. And that would be our simplified fraction there. If you have questions, mark them down, bring them to class, and I'll answer them in class. Let's look at the next one here. So this one, we've got 1 plus 3 over x plus 2 over x squared, and then that whole entire fraction there, or that numerator, is being divided by the expression 1 plus 2 over x. So if we look at our denominators, we have obviously 1, but we're not going to worry about 1 as much now because it's not going to change anything. We have x squared, and then we have x. And I think we already did one like this as well. We want to multiply by something that is divisible by x and x squared, and that would be x squared. So our least common denominator here is going to be x squared. So we're going to take this here, we're going to multiply the top by x squared, and then we're going to multiply the bottom by an x squared. So when we do this, right, we're going to multiply x squared times 1, which is going to give us x squared. X squared times 3 is 3x squared, and then we're going to cancel out an x, so we have plus 3x. And then x squared times 2 is 2x squared, and then we're going to cancel out the x squareds, leaving us with just 2. So we have x squared plus 3x plus 2. On the bottom, when we do it, x squared times 1 is just x squared. And then x squared times 2 is going to be 2x squared, divided by x would be just 2x. Now this one, since we're dealing more with polynomials, we have to look at this now and say, hey, can this simplify down? And in order to do that, we're going to need to see if they have any common factors between the numerator and the denominator. So let's go ahead and factor the numerator. It should factor into x plus 2 times the quantity of x plus 1. And the denominator here, it looks like we have a common factor of x. So if we factor out that x, we'll have x times the quantity of x plus 2. And now we can see here that we've got the quantity of x plus 2 is a factor in both the numerator and the denominator, so they will cancel out and leave us with x plus 1 over x. And that will be our simplified fraction. Next one. We have 1 over b minus 1 over a, and that's our numerator, and that's being divided by 1 over a squared minus 1 over b squared. So when we think about our denominators here, we have an a squared, a b, and an a. And we already did that one at the beginning as well. If you flip back a couple slides in your notes there, we said that the least common denominator for something like this is going to be a squared, b squared. So we're going to go ahead and apply our procedure here. We're going to multiply the top by a squared, b squared, and the bottom by an a squared, b squared. So be careful when you do this, right? We're taking a squared, b squared, and we're going to multiply it times the 1 over b. So when we do that first, we should end up with, I'm going to write it below here, a squared b. And then we'll have minus, when we do a squared b squared times 1 again, and then cancel out an a, we'll have minus ab squared. Same thing in the denominator. When we do a squared b squared times 1, and then cancel out our a squareds, we should have a b squared. And the second one there, we'll have minus a squared b squared times 1 divided by b squared will leave us with just an a squared. Now, same thing as the last problem, we're going to go ahead and we're going to try to factor these. In the top, it looks like we're going to have common factors, right? They both have a's in them, and they both have b's in them. So we're going to go ahead and factor out an ab. So when we factor out an ab here, the part that's left over then should be a minus b. And if you're not sure, go ahead and distribute your AB through to double check to make sure you get the same answer back out that you started with. On the bottom, we have a difference of squares, so we can go ahead there and factor that. That would be b minus a and b plus a. So as we look to see, does anything simplify here, we'll notice here that we've got the a minus b and the b minus a. Remember, those are opposites, so if we cancel those out the way they are, just one of them needs to become a -1. Or you could factor out the -1, make them the same. That's up to you which way you want to do it. If I do a times b times -1, I'm going to have a negative ab left over on the top. And on the bottom, this is just like a 1, right? And 1 times the quantity of b plus a is going to be b plus a. Nothing else will cancel out here, right? Because this is a factor, and then a is a factor, b is a factor, and then -1 could be a factor there. So there's nothing that matches there. So our answer, negative ab over the quantity of b plus a. Next one. Now we've got 2 plus the fraction 2 over 3 minus x, and then that's our numerator, and we're dividing that by the fraction 4 over x minus 3 minus an x. Okay, so when we look at this here, first thing to notice here is the only real denominator we have contains an x minus 3, and then the other one has a 3 minus x. Okay, so remember these are opposites. So, I mean, if we were trying to cancel something out, let's say we had 5 and -5, could we cancel out the 5s here? Yes, we could. Let's say it was a fraction there, it would just leave us with like 1 over -1 or -1. So it's kind of like our least common denominator here is looking like we could just go ahead and use either the 3 minus x or the x minus 3. In this case, I'm going to use the x minus 3 because I think we're more used to seeing a binomial written like that versus the 3 minus x. So I'm going to take this here and I'm going to multiply the top by an x minus 3. And then I'm going to multiply the bottom by that same quantity. So when we distribute this through, we're going to do that times a 2 first. We're going to have 2 times the quantity of x minus 3. Then we've got plus. And when we do that x minus 3 times the 2, I'm going to go actually and write this out on this one. We'd have 2 times the quantity of x minus 3 over that 3 minus x. Okay, remember this is like all in our numerator of our fraction. And now I'm going to go ahead and do the bottom part here, and then we'll look at simplifying them there. So if I do this quantity of x minus 3 times the 4 over x minus 3, that's what we have. And then minus x times the quantity of x minus 3 when we do it times it there. Okay, so if we want to simplify this down, right, because we still have fractions and fractions, let's start out here with this 2 times the quantity of x minus 3. We can go ahead and distribute this 2 through, right? We can do that there. That's going to give us 2x minus 6. And now right here, what we've got going on, right, x minus 3 and 3 minus x, if we cancel those out, remember they're opposites, that's going to leave us with a negative 1. So what we really have here is plus a 2 times negative 1, right? So if we said that, it'd be like plus 2 times negative 1, but really that's the same thing as just saying here 2x minus 6 minus 2, right? Because this is just like the same thing there, which is in the end they're going to give us 2x minus 8. Remember, these are all in the numerator still. And then when we do our denominator, we've got the x minus 3 and the x minus 3 are common factors, so that's just going to be like positive ones there. So that's going to leave us with just the 4. And now we're going to need to take this negative x and distribute it through here. So remember, take this negative with it. You're going to end up with minus x squared plus 3x. And if we wanted to rearrange the order in this part right here, right, because you don't really see your trinomials written that way, let's put it in more of a standard form here. We're going to have negative x squared plus 3x plus 4. And for me, I don't like dealing with this negative x squared, so I'm going to factor out the negative 1 and just flip all the signs. So I have a negative 1 times the quantity of x squared minus 3x minus 4. And let's just recopy that down here. Now remember, you don't have to show as many steps as I'm showing. I'm just trying to make sure that anyone who doesn't understand can follow along. So now we can take it and look to factor these here to see if there's anything that will cancel out. We have a greatest common factor of 2 in this numerator here, so that's going to give us 2 times the quantity of x minus 4 over, still have this negative 1, and then our trinomial should factor into 2 binomials if it factors. Should have an x and an x, should have a negative 4 and a positive 1. Well, that should help us here now because we're going to look at our quantity of x minus 4 and quantity of x minus 4 will end up canceling out. And we now have 2 over a negative quantity of x plus 1. And it's, your choice how you want to write it. You can leave that negative down there. Some people may take it here and write it in front of the fraction bar, like this. And then they don't need the parentheses in the bottom. Or they may even take it here and write negative 2 in the top and then have it over x plus 1. Any one of those is perfectly acceptable there. They all mean the exact same thing. I'm just going to go ahead and just leave it at that one since that's the last one I wrote. And that's it for this. So if you have questions, please make sure you bring them to class and ask. Thanks for watching.